Good morning, good afternoon, good evening to everyone. Welcome. Welcome to the participants in this panel and welcome to the audience as well. This is the 6th in our series of global salons. I'm sorry, this is the 7th in our series of global salons on critical topics this year. Over the last 4 months, the Einaudi Center has hosted a fantastic cross-disciplinary, cross-regional perspective on a set of important issues from future cities to democratic challenges and change, inequality and social justice, migrations and mobilities, big data, AI and new media, One Health and sustainable agriculture. All of these salons on important topics are available on the Einaudi Center website. And today, we're really excited for this conversation on the topic of sustainable energy and infrastructure. The participants in this conversation are from Cornell's Global Hub partner universities around the world. The Global Hubs, these are partnerships that are intended to deepen connections and build educational, research, and engagement exchange in order to help all of us address some of the most challenging and important questions in front of us. So thank you to everyone for joining and participating, and thank you to Rachel Riedel and the Einaudi team for organizing and hosting. I'll turn it over to Rachel, who is the John S. Knight Director of the Einaudi Center.
Thank you, Wendy. And thanks to all of our participants and panelists and audience members for being here and helping us to start this conversation today on global sustainable infrastructure and energy. In particular, I want to invite our audience members to share your questions, your ideas, your reactions, your own research centers and projects that are ripe for collaboration in the Q&A function, and we'll use those to further the conversation after we've gone through each of our panelists' introduction and in order to continue this conversation and allow for the engagement of our audience. We'll use these questions and conversations to really as a springboard for the next step of potential collaborations as we launch this thematic topic today with all of our partners from across the globe. I want to be particularly brief because we have an amazing set of experts to get to, and I'm just going to briefly explain the charge that we've given to each of our panelists, which is to do 3 things. First is to give a brief introduction of their own work, the cutting edge research that they're engaged in. The second is to share information about their initiatives, groups, centers at their home university and collaborations that they're a part of. And the third is to engage in a thought experiment about what is the cutting edge future of this research agenda, of this topic area that can best be facilitated and indeed often can only be pursued through interdisciplinary and multilateral research collaborations from across the globe. That is to ask, how can this conversation of leading scholars meaningfully move us forward to take up next generation questions in this topic area? So with that, I'm going to pass it over to our first panelist today, Dean Lynden Archer of Cornell University.
Lynden, you're muted.
Is that better? Good morning, everybody. As you've heard, I'm Lynden Archer, Dean of the College of Engineering. And it's really a pleasure to be here. So what I'd like to do is to first of all, give you a quick perspective on one component, I think, of the sustainability infrastructure, and that relates to cost-effective storage of electrochemical energy in batteries. So let me provide a little bit of context to get this discussion started. So I am not an electrochemist. I'm in fact a chemical engineer. And I got really excited when in 2008, the National Academies in the United States issued their so-called 21st Century Grand Challenge questions for engineering. And these are the 10 questions, right? So affordable solar energy, energy from fusion, food, water, and so forth. I got excited about the top 2, in part because these were perceived to be very, very hard problems. And so one of the really shocking things for me as a scientist has been the progress we've made in fact, that first bullet, affordable energy from solar. And in fact, what this chart shows you is just the remarkable drop in the amortized cost of energy from the sun, right? So in 2008, it was something like $200+ a kilowatt hour. In 2019, 2020, the price had already dropped to 5 cents a kilowatt hour, meaning that renewable energy generated from solar installations was competitive with energy generated from fossil fuels. Now, not to be left behind, wind caught up, and renewable energy from wind is now 3 cents a kilowatt hour, which again is quite remarkable. Now, I think everyone in the room knows what the elephant is in the room, right? That these sources are intermittent, they're seasonal, and so to basically make good use of them, they've got to be complemented with as cost-effective storage of electrical energy. Now, the US Department of Energy just last year captured this need in what they're calling the Storage for Long Duration Grand Challenge, or EarthShot. And their goal is to get to 5 cents a kilowatt hour for levelized cost of storage, which is far away from where we are today. So just as a quick perspective as to how we fare today, right? So today, the vast amount of storage that complements electric power generation from solar wind is based on a technology that's called pumped hydro. And this technology is illustrated to the left of my chart. So the idea is that energy is generated. One uses the extra energy to basically provide potential energy to water that you then send uphill, for example, to a lake that's at a high elevation. And then when you need the energy, you basically release the water so that potential energy does work against a turbine, and that generates electricity. So that technology makes up about 95% of all storage today. And so the question is why? Well, it's pretty straightforward, and that's indicated on the left bottom. The cost is less than 10 cents a kilowatt hour. So our vision is to use innovations in energy storage and batteries to bridge this gap. And so the inspiration for this vision actually is in this very busy chart that I think hopefully you'll be able to go through carefully. But this chart provides a map. It basically tells us that if we can use metals, these are the elements in the lower quadrant of the chart, so sodium metal, zinc metal, aluminum metal, metals that are earth abundant as the anodes in batteries, it's possible to get the cost at the purchase scale to $1 a kilowatt hour. And if these batteries can be cycled over long periods of time, it is probably quite easy to get it to 5 cents a kilowatt hour. And that's where my group innovates, how to make these very difficult metals, battery anodes that can be cycled. And we're making really good progress that I'd be happy to share with you. So just quickly, in terms of the second question, this work requires large infrastructure to study materials at a very small scale, ironically. And so we use CHESS, or high energy synchrotron source on campus, which is just world-class to characterize material structure needed to enable these batteries. We use Paradigm to make materials that are quite precise, the Center for Materials Research for characterization, and of course, the Atkinson Center that provides a broad overlay of these activities. So I will just stop here because I see a red background on my screen, but really exciting stuff, and I would be happy to partner with anyone who has interest that are complementary. Thank you.
Thank you so much, Dean Archer. I think you've laid out exactly the future research agendas with the research that your team is doing. So we really appreciate you kicking us off. Next, we'll move to Dr. Catalina Sparatu from University College London.
Hi, everyone. Good morning or good afternoon, everyone. It's a pleasure to be here. I'm a professor in global energy and resources and the founder and the head of UCL Islands Laboratory. But also I'm the director of Energy Institute. So I'm coming from an interdisciplinary and multidisciplinary background and thinking, and my research underlines an integrative approach and potential solution around energy and resource nexus, climate change resilience, governance of resource use, and we are looking at pathways towards maintaining the physical basis of society and socioeconomic values in the long term. Some examples of the work includes energy system modeling, analyzing the impact of renewable integration and interconnection in Europe, in West Africa, in islands like Greek islands, Turkish islands, Another work I've done is on the theft of gas and electricity in the UK for utilities. From a practical work, an example is the development of a real-time location system model for 3D location for indoors to address some of the many challenges associated with the energy efficiency refurbishment of existing homes needed to help meet carbon reduction targets. In other words, I'm really well known for leading development of interdisciplinary toolboxes in large project consortia in the area of resource nexus and sustainability. And such an example is the current project I'm leading called Re-Energize Governance of Disaster Risk Reduction Resilience for Sustainability Development, which is funded through Belmont, where I brought together a multidisciplinary team, cross-disciplinary, institutional and geographical boundaries from 11 universities, from 4 continents and 7 countries. And I'm leading the design of a toolbox which explore through a nexus-informed methodological approach impact of floods, droughts, and heat waves on resources and infrastructure and sectors, taking quantitative and qualitative data models and methodological approaches like values and principles into actionable insights to help building resilience in islands and coastal cities. So we use artificial intelligence, machine learning, natural language processing together with resource nexus approaches, multi-stakeholders involvement via surveys, interviews, workshops, and methods like Policy Delphi and Q methods we utilize. Another example of the work is energy markets and regulations, part of another consortium called Open Piazza, which was led by industry, where a consortium of 7 businesses and 2 universities from UK and Canada, we work together to develop a digital platform to help build environment to sustainable energy by assessing the benefits introduced by energy storage and generation and the business case needed to justify the required investments. So the process is facilitated by an online platform that allow users to configure their own assets and run a computation through the digital platform to estimate the carbon emissions reductions, and this will really help companies to effectively forecast efficiency and evaluate solution for implementation of sustainability solution. So we are doing really broad work and research. We are working closely with companies, but also with universities around the world.
Thank you so much, Dr. Sparatu. In fact, the work that you mentioned on islands and coastal cities in terms of actionable resilience really taps into one of our earlier salons on future cities. And a lot of discussion there was around resilience. And so we could connect you there as well. Next, we'll move to Dr. Erasmus Mwanmo from University of Zambia. We're not
Am I
here.
clear now? Thank you very much.
Thank you.
Thank you. I'm going to look at the rapid assessment of the Urban Community Optimization Public Health Intervention Project. It looks more on health, but clearly it does address solid waste generation, storage, disposal, as well as its contributions towards energy generation. So our project really is, we have about 5 projects in our center, but 2 of them that have just been funded by the Royal British Academy are going to run concurrent. One looks at the good city, and the other one is the one that looks at the waste generation. And so we want to see how we can now move this energy that is being accumulated throughout the towns and the cities in the this part of Africa, and then see how we can now use them to generate energy. But at the same time, I'll also look at, just to show you how much we have in terms of materials in this part of the world and how that material can contribute towards the current thinking of sustainable vehicle production, more about the batteries production. So this, this project looked at about the landfills And our landfill receives about 60% of the waste, which is lying all over the towns and the community. 70% of that comes from peri-urban, and only about 12% is being recycled for other uses. So we have 60% organic, plastic around 12 to 15%, and the remaining 1% is metal. The 60% organic can be very useful, but this is what it does. For those that are still having meals, please pardon me. This is just in one area of the town and just shows you how waste, if not put to good use, can become a serious hazard. And yet we can see some very young ones being able to collect some of the waste for recycling, the majority of which just is left to be dumped. And then it's also clogged some of the streams within the city's poor areas. But considering the biogas production, using various technologies, apart from just using the crop foods and other productions, we can still produce biogas from the similar waste as we have seen. And then at the same time, we can now generate energy which can stop the community that goes into destruction of the forest for firewood and charcoal to go into the gas, which can then be utilized as a sustainable energy, and also just protect the forest. This is just to stray a little bit on the storage of another project that we have. More on the other side, we are at the stage of coming up with the batteries, and this just shows you within the SADC region just how much minerals we have that drive the agenda of the electronic vehicles, but at the same time more on the battery storage for energy. So while we are looking at generation through hydro production or any other means, solar and so forth, the large part of energy generation gets to be stifled because of the storage aspect. So we have done an assessment and we can see that we are well positioned. We are right there as a country. And from that point, we are now able to see that we have all the necessary minerals that can come up with a lithium related battery storage facility. So we are at that stage, but we have almost gotten to a stage where we can produce the battery. So in conclusion, it's just to tell you that we do have a poor waste management that is also affecting the water quality, the disease, and also we lack funding for these type of projects and even developments. But opportunities are there for recycling that could also generate energy in various forms. So I thought we could end there for now.
Thank you so much. We see already many connections between the first three panelists, which is ideal. And indeed, Zambia is at the forefront with so many of these mineral contributions as well. Next, we'll move to Dr. John Dunn from Universidad San Francisco de Quito.
Thank you very much. Thank you to Cornell University, and thank you for letting me share with you what is the basis of my explorations as an architect and as a teacher. I'm talking about the replacement in the architecture, the architecture speech, about the term function for the word use. This opens a bigger picture for sustainability in architecture, since use is not specific, and we can give many other chances to the build-up form to still be useful. We have some contradictions in the conventional framework of sustainability based on reusing, reducing, and recycling. Reduction is hard to get in a consumption-based market, and our excessive reliance on recycling does not stop pollution. However, the reuse of a building or other kinds of infrastructures help us to avoid pollution by construction and the energy consumption that it requires. If we change the way we use an architectural object, we may increase the advantages we get from it. This could be applied not only to what's already built, but also in architectural typologies. As a consequence of these explorations in my professional practice, I've developed a couple of interesting proposals which have been recognized on international competitions. One of them was the idea of inhabitable docks for the slums built over the estuaries of Guayaquil. The other was floating parks for the Guayas River. These barges would work not only as a public realm, but also as an innovative transportation system. As a teacher, I've been related with the USFQ Galapagos International Architecture Workshop, in which we explore the relations between human development and nature-preserved areas. One of the favorites that I've been introduced, one of the favorite studies that I've done there was related with the idea of the Black Swan events on the archipelago, to introduce the idea of the Black Swan events on the archipelago, and how can we use architecture to deal with these very unexpected scenarios. When we did this, the students started to explore some ideas like how to deal with the rise of the oceans by climate change, or what could be done if we have to reorganize the political structure of the islands. I mean, even we explored what could be developed if the population relied much more on rainwater just to keep it safe. The explorations developed by the students were not only better than expected, that helped us to confirm that through the change of views in architecture, we can give new answers to the same questions that mankind tries to resolve through design and architecture. Thank you very much.
Thank you so much, Dr. Dunn. Really fascinating and connects strongly through some of our colleagues in architecture and planning here at Cornell as well. Next, we'll move to Dr. Tauren from Shanghai Tong University.
All right, can you see my slides?
Yes, thank you.
Okay, so good morning, good afternoon, and good evening, everyone. My name is Tauren from China UK Low Carbon College of Shanghai University. So my research is related to carbon dioxide. If I give a big name for my research, it could be carbon in flame and carbon in atmosphere. So this is my lab. My research is closely related to carbon dioxide. So my lab is carbon dioxide related thermal radiation. I have three different research directions. The first two is about combustion, understanding combustion with radiation, so which helps in understanding combustion and make combustion more efficient and clean. And the last one is about using spectral radiation measurement to understand the greenhouse gas concentration in the atmosphere. So those for the first two, and this is for the last one. So very recently, we used the hyperspectral measurement for flames, and use machine learning help us to get the three-dimensional temperature, carbon dioxide concentration, water vapor concentration, and carbon monoxide concentration simultaneously. Those are some experimental measurements from this hyperspectral measurement with machine learning. And we also use machine learning help us to get the carbon dioxide in the atmosphere. We use machine learning to predict the atmospheric gas spectral properties, to do satellite spectral simulation, and use machine learning model to predict carbon dioxide from the satellite spectral measurement. And those some result we predicted for the Australian for a period of 6 years. So next I'm going to introduce something about low carbon college at Shanghai Jiao University. So carbon neutrality is a very hot topic in China since 2002 to 2020. However, long before that, Shanghai Jiao University has opened a brand new college, which is the China UK Low Carbon College in 2017, to deal with all those issues that are important for achieving carbon neutrality. So I'm going to introduce the research we do here at the LCC. Next, so this is some of the picture we took on the first day when we opened the Low Carbon College. So the China UK Low Carbon actually is the first college in China, pioneers in low carbon research and education. Here's some pictures of the university, of the college. And on the very first day, we have launched 5 research centers, including carbon finance and carbon management, smart energy and big data, renewable and energy storage, carbon capture, this is CCUS, sustainable technologies and waste resource utilization center. So there are many challenges we face today for achieving carbon neutrality, but we think those centers basically covers everything for dealing with those challenges. So it's time to work together and dealing with all those challenges together, I think. I think that's why we have this salons today and we are together today. That's all from me. Thank you very much.
Thank you so much. That's really, really so many opportunities to connect there. Next, we'll move to Dr. Abrihu Chowdhury from OP Jindal Global University.
Hello, this is my honor and to be here and discuss about sustainable energy infrastructure. My work, I am a professor and assistant dean student affairs at OP Jindal Global University. My work mostly pertain to deltas. I work in Indo-Gangetic Delta and try to find out the vulnerability due to disasters and how sustainable energy solutions can be one of the models. So this is the delta. It is not only very vulnerable to natural disaster, which is definitely it is. Every year we are anticipating or getting super cyclones. They are disturbing lots of areas. This is also a very densely populated region. About 4.6 million people live only in the Indian side of it. So 60% of this delta is also with Bangladesh. So this is a huge area with a huge population, but there is a huge problem of energy paucity, because whenever there is a disaster, all the overhead lines that would be taking energy from different thermal power centers to different parts of the villages and these islands totally get disrupted. So the people will be without electricity for 3-4 months at a time even. So in that context, we come down to the solution of solar lamps. So when this kind of disaster strikes, this really make a difference in the life of the people, which is huge. Almost 54 islands has human population. And during the time of disasters, a solar lamp is something that will keep on giving the energy and light to the people until the electricity is restored. So my entire work revolves around finding solutions of catering to these technologies in the remote locations of and disaster-prone regions. As of now, we are working mostly in the deltas, but we are also trying to work in other parts of India also that are having similar disaster vulnerability, which is increasing day by day due to climate change and sea level rise. Now, talking about my university, it is one of the leading private universities of India, already in the QS ranking. We have partnership with the different institutions globally, and we are trying to get even more collaborations who would be interested to cater out solutions of sustainable energy to the places where they really is needed. Like, for example, in the very densely populated deltaic region, which has energy insufficiency and is suffering from lots of problem during the time of disaster. So we have different collaborations that are going on, and we are also have collaboration with different local NGOs, because working in these areas without the help of social civil organizations is very difficult. We have already working in this area through their help and support, and but we do need some support and technology that can be easy and cheaply available maybe for the people to easily adapt to them. Thank you.
Thank you so much, Dr. Chowdhury. Wonderful for sharing that with us. Next, we'll move to Dr. Katherine McComas at Cornell University.
Hello, everyone. So I am a social scientist, and my area of research is around risk communication. And one of the questions that I think is very relevant to a lot of what we're hearing today is that there are an amazing amount of approaches to design renewable energies and to deal with the existential challenges that we're facing. My questions are, but will people accept it? And what are the factors that influence this? And so in my research, I look at issues of process, and I look at issues of risk perception. One particular example is around deep geothermal energy. I'll just take that as an example. We're looking at that at Cornell, and I know many other countries are looking at enhanced geothermal and geothermal energies. One of the challenges is that at times, this type of energy has the potential to induce seismicity. So part of my research is, which I call acceptable earthquakes, is the extent to which people are willing to accept trade-offs, including the potential for human-induced seismicity, in light of the benefits, including a renewable energy. I look at issues of process, beneficiaries, and other types of factors, including experience with earthquakes, as well as experience with extractive industries and fossil fuels. Next, I'll just note a couple of other aspects of Cornell. I also co-chair on the Sustainable Cornell Council, the Education and Engagement Committee, which looks at how do we imbue across the university, and particularly in our undergraduates and graduate students, a literacy in climate change and sustainability, and how do we chart clear pathways for these students when they come in to partake in this, so that when they graduate from the university, they're really able to realize and help to work in these areas in whatever way they can. So I'd be very interested in learning from others about how they're doing it at the university and sharing what we're doing. Lastly, I'll just mention also, I co-see the David M. Einhorn Center for Community Engagement, which has an ambition of trying to, across the curriculum, have students work with community partners, with partner organizations to solve real challenges. And many of these challenges, as we know, are in engineering, as well as throughout. And so through the curriculum and outside of the classroom, we're working to put students with faculty and staff in connection with community partners to try to provide the students with real world experience while they are indeed going through their education. But really it is, how do we work to benefit our community partners, and how do we work to solve these challenges together? And again, I'd be really delighted to share with anybody what we're doing, as well as to collaborate to grow opportunities on your campus or throughout. So I'll stop there, and thank you very much.
Thank you so much, Dr. McComas. I think that's really such an important aspect in terms of looking at the social dimension and take up and perceptions. So thank you so much for sharing that with us. Next, we'll move to Dr. Kiangheng from National University of Singapore.
Thank you. Let me try to share screen. First, give me a second. Can you see my screen?
Not yet. Oh, here it's coming. Yes. Yes, we see it. Thank you.
Okay. And then you're going to, okay, I have to stop the screens. Okay, thanks. So I'm from National University of Singapore, and I currently run the Center for Sustainable Asian Cities at the College of Design and Engineering. In fact, it's a new college that is formed by the merger of the Faculty of Engineering and the School of Design and Environment. So it's less than 6 months old, although the separate entities have been there for a long time. So I teach urban planning graduate studios, and also a module on principles of sustainable urbanism. I am a architect planner. I do a lot of planning and work closely with government agencies on research and planning of future urban areas and new towns in Singapore in the face of the emerging trends, both local and global challenges. So our trends are like new work practices, mobility systems, sharing economy, distributed healthcare delivery systems, renewable energy, etc. And we have challenges like aging population, food security, and of course global ones like climate change, pandemic, etc. So our school is a large one, our college is a large one. We have about 11,000 students and 2,000 staff members. So there's a lot of research being done in different labs and groups. So here are some of them: Urban Climate Design Lab, Carbon Capture and Storage, Circular Economy and Sustainability, Green Energy and Technologies, so on and so forth. So some of them are more in the building scale, some are in the technology scale. So the building ones are like building energy efficiency and indoor environmental quality, urban analytics lab, etc. So there's a whole range of spanning from architecture and urban planning to technologies of different kinds. that you can see a selection of some of those centers and institutes we have here on the slide. So, given my own background, I'm a fervent believer that for sustainable cities to be planned and designed, you need, or rather sustainable development can only be achieved through very ingenious design and the application of, well, appropriate technologies, many of them are new, and of course responsible behavior. And so at the college, for the design and planning part of it, we straddle all these different scales, from the building scale to the neighborhood scale, to the city scale, through planning, and to the extra large architectural scale through planning and landscape architecture. And as I've shown you earlier, there's a whole range of technologies, and our colleague that our colleague worked on at CDE. And for behavior-wise, since NUS is a comprehensive university, we have colleagues working on this aspect from the Faculty of Arts and Social Sciences. So with that, our concern is how to build a sustainable city at all scales. Thank you.
Thank you so much. That connection between design, technology, and behavior really encompasses all of the presentations here and draws upon Dr. McComas's work on the behavior side, as well as all of the technical and design aspects. So thank you so much. Next, we'll move to Dr. Christos Marquitas from Imperial College London.
Hi, thank you very much. All right, so I'll try to keep this nice and brief. I know that we're under time pressure. So that's me and my email in case anyone wants to get in touch with me. I'm here, of course, to tell you a little bit of my own research, but I represent not just my own laboratory, but also a couple of other entities at the college that I'd like you to be aware of, because there's a lot of work, of course, going on in sort of large institutions and universities like ours. So I'll tell you a little bit about, I think, specifically something called the Energy Futures Lab, which is a cross-departmental sort of multidisciplinary institute at Imperial. So these are sort of 3 screenshots I took literally before this series of presentations started. On the left-hand side, you'll see the Department of Chemical Engineering. I noticed that there's at least one other chemical engineer here on the panel, so there's a lot of work going on. You'll see all sorts of little research themes. One of them, which is in energy and environmental engineering, you can imagine there are a lot of related work. On the top right-hand side is what we call the clean energy processes. That's my own team, and I'll tell you a little bit about that. So I have a sort of a dedicated slide. And I'm also here presenting something called the Energy Futures Lab, which I introduced very briefly on the previous slide, which is a cross-departmental or cross-disciplinary institute, which has a number of research themes, one of which is called energy infrastructure, which I tend to be the theme lead of. So there's a lot of work that's going on there, as in collaboration with, of course, a lot of colleagues across different departments and disciplines and so on. So what about specific or rather research interests? Let's get down to that level now. So we tend to take the view that in order to develop technology, you need to understand fundamentals, and there's all sorts of very nice developments going on, from new materials, new fluids, processes, intensification, and so on, to technologies themselves. So one level up, right? So new fancy things. There was a mention of energy storage, I think, in the beginning of this panel presentation. But there are many, many interesting technologies that will play a role. And then, of course, energy systems work, which is at the highest level, what you might consider sort of answering questions of the type, what would be the role of different technologies within wider energy systems? What's the potential to decarbonize? What would be the cost at the societal level, trying to bring in some of the policy, social kind of elements to basically designing energy strategy moving forward. So all of these things are sort of active, and there are people working on this. In terms of my personal interests, and maybe just to kind of throw a few things out there to just start a discussion with people. I have an interest in solar energy, and specifically something called hybrid photovoltaic thermal systems, where you have solar collection systems that tend to do more than one job. So they would generate electricity and useful thermal energy, or cooling, or desalinate water, or some additional function. So going beyond just simple PV systems. We have a lot of interest in waste heat recovery. So there's a lot of wasted energy. This forms part of a wider kind of push to improve energy efficiency. We have interests in energy storage. Again, this was mentioned earlier, but we focus specifically on storage of thermal energy, either directly or through thermomechanical systems. And we do a lot of modeling and development of technology, assessments, and of course we have this interest, as I mentioned before, in trying to feed some of that information on the technology and the performance and the characteristics of different technologies into what's called whole energy systems, to try to understand, right, how a national energy strategy should evolve, what potential these technologies have to make an impact at the national level, and so on. And I just have this one last, I guess, point to mention at the bottom, which is a sort of a flagship project in this area called the IDLES project, which stands for Integrated Development of Low Carbon Energy Systems. This is an Energy Futures Lab project. It's relatively large. It's a sort of, I think, $9–10 million US project, which brings together a lot of people all the way from technology, social aspects, energy demand, whole energy systems, the kind of things that I mentioned before, to try to understand how we can do these things at a national level. Thank you very much.
Thank you so much, Dr. Marquitas. Next, we'll move to Dr. Davis Bookhart from the Hong Kong University of Science and Technology.
Hi, good evening, good morning, everyone. Very pleased to be here. I didn't think that I could show some slides and stay within my 3-minute limit, so I ditched those and I'll just go right into what we do. I'm with the Sustainability Net Zero Office, and we really have 3 things that we're focusing on. The first is looking at our 2 campuses and really thinking about very specifically, how do we build the strategies to get to net zero? And I call it sustainable net zero, and I'll explain that in just a second. The second thing that we do is we focus on sustainability education. And so we recognize that universities are transitioning away from traditional content-based instruction. We're moving more into skill building and competencies. And so we use that as an important role, because sustainability thinking aligns very well with skill building. So we've just formed something that we call the Life Cycle Lab. And we feel like life cycle thinking, which involves looking at supply chains across the entire systems, is a way that students across the curriculum will be able to understand fundamentally, conceptually, sustainability. The third thing that we do is we support research and demonstration through our Sustainable Smart Campuses Living Lab initiative. We have some funding and staff members that can support our researchers to bring their research to a proof of concept on the campus. We do that as a way to try to bring the education out of the classroom and also support our researchers as they're moving forward. So the things that I'm particularly, obviously, I'm very interested in sustainability net zero by 2050. I think I've always been involved in sustainability planning, but they've been incremental. We can get to 2025 or 2030 through incremental means. But the 2050, if we're really following the science-based targets, it means that we need to fundamentally change what we have. So we've been really focusing on future thinking, scenario planning. What does the world look like in 2050? What does our campus look like in 2050? If we're moving away from unbundling some of the things that are traditionally connected to a university, then how does that impact our energy consumption and our ability to get to where we need to go? And because of this, we're also looking at the kinds of energy systems. We recognize that the one-way flow, traditional one-way flow of energy into the consumer is really going to be a thing of the past within the next 20 to 30 years. There's a lot of talk today about about energy storage, so looking into non-traditional energy storage, like, automobiles will be having a significant number of EVs at some point on campus. How do they become the energy storage and be able to discharge back into the grid when we need it the most? So I'll leave it there. I hope to speak with some of you more on some of these issues, and thanks for inviting me.
Thanks so much, Dr. Bookhart. That's fantastic and really presents so many opportunities for collaboration. Next, we'll go to Dr. Daniel Nupeza from University of Ghana.
Good afternoon, and thank you for inviting me. My name is Daniel Nupeza. I'm a senior research fellow with the Institute for Environment and Sanitation Studies at the University of Ghana. I have an interdisciplinary background with a PhD in environmental science. My research interests have been in pollution control studies in inland waters, ecosystem-based disaster risk management, circular thinking in industrial systems, and in recent times, sustainable infrastructure and energy use. I would like to share with you a collaborative project that we are undertaking with the University of Liverpool. And the title is Keeping Your Cool, Modern Architectural Heritage and Climatic Comfort in Ghana. The aim of this particular project is to investigate the climatic comfort of naturally and mechanically cooled buildings in Ghana. In other words, the aim is to answer the question, to what extent do tropical modernist structures modify or mitigate climatic conditions to create more comfortable interiors? And this is against the background that the current climatic comfort standards and modernist building designs being deployed in Ghana were not intended for the tropical climate. I'd like to use this very image to explain that. If you look at the image on the left, that's an image of a building that was built maybe in the 1930s, 1970s. And we can see clearly that such a building, when you look at the exterior of the building, it has a permeable facade that is composed of concrete screens and sometimes louvers to facilitate cross ventilation, airflow, and to create shade. But then later on, as the years go by and during refurbishment of said buildings, we see on the right that we have the building clad in glazed panels and reliance on AC, and that indeed increases energy costs. So our research is to investigate how, whether that extent to which tropical modernist structures can modify or mitigate climatic conditions and to create more comfortable interiors, like I've said. And what we've done in this investigation is done through two procedures. We've been looking at heritage buildings or colonial buildings. One of the buildings that we are looking at is the BAM Library at the University of Ghana. We are doing this study through census and surveys. And what we've done is that we've used temperature and humidity data loggers to record the internal and external thermal performances of this particular library building. And the difference between the internal and external readings should give us some indication of how well the building manages to modify and mitigate the climate through shading airflow. And we've also done that through surveys. And in this case, we examine how users of the building perceive the climatic comfort within the building. And we think that with this ongoing research, we actually intend to develop revised comfort standards that's based on data that is gathered within from within Ghana. Now, what is the future of this research agenda that could be facilitated by an interdisciplinary multilateral research collaboration? How could this conversation of leading scholars meaningfully move forward to take up the next generation of questions? And I answered this in particular reference to our ongoing research, that there is an opportunity indeed to expand this research to large buildings that have a potentially high cooling energy demand. In other words, can this be upscaled? And can similar studies be done in tropical climates? We hope that, with effective collaboration that is provided, that will also provide a needed traction for sustainable infrastructure and efficient energy use revolution in Ghana and beyond. And indeed, this study should have implication for the development of green architecture and to reduce energy demand in buildings, especially buildings in the tropics. Thank you.
Fantastic. Thank you so much. I love this combination of looking at the historical perspective and buildings as we think about, we've heard from so many of our speakers today about future technologies and thinking about that intersection of what is sustainability really built around. So thank you so much. Next, we'll move to Dr. Oliver Probst from Tec de Monterrey.
Yeah, hello to everybody. Thank you very much for this invitation. It's a pleasure and an honor to be here. I would like to talk about climate change and energy transition from a Mexican perspective. Very often in academic circles, and I think this session is not an exception, we tend to spread the idea that everybody agrees upon climate change mitigation, and it's all about technology and getting the costs right and take it from there. This is not true. I can tell you from 20 years of experience of developing wind farms and renewable energy installations in Mexico that we're up against a significant resistance. And I will provide a brief country description of Mexico as far as climate change is referred. Before 2018, we're still slowly moving towards an agenda of climate change mitigation and decarbonization. And one major milestone was the 2017 auction on clean energies, electricity, when we achieved a target below $20 per megawatt hour, which was a world record by that time. Since 2018, things have changed dramatically, and basically the current government is trying to purge private participation in the energy sector, and particularly aiming at renewable energy. The government has undertaken several measures which were largely unsuccessful because they were stalled at the courts, at overturning the electricity reform, abolished competition, and nationalized the power sector. So this was basically based on ideology, not on cost or any other arguments of that kind. In spite of the failure at the courts, the government has been successful at stalling renewable energy developments, delaying fully permitted projects, and curtailing renewable energy production. In the hydrocarbon or gas and oil sector, we have seen similar situations. There was a clear mandate to ramp up gas and crude production, and this had led to a number of problems which are illustrated in the following points, but I won't go through them very much. But we have really an environmental string of environmental hazards in Mexico because of this ideologically motivated situation. So what can be done from academia to address this kind of problem? This is not about building a better technology, it's but dealing with a situation which is largely irrational, which is about power, it's about ideology. So what can we do from academia? Well, we've done some damage control. We've been preparing technical expert opinions on the electricity sector to rule out some of the mysteries that have been, some of the urban legends that have been spread about renewable energy and the alleged lack of reliability. We're setting up a full semester course, a so-called concentration on decarbonization and clean energy, and this is intended to shape a generation of new leaders in the field that will have a complete and comprehensive view of what's going on both technologically and in politics, and what is going on on the regulatory side. And we're partnering, that's a mandate on our institution, partnering with industry and government and non-governmental institutions. From the research side, very briefly, much of our research has been focused on the electricity sector, and basically monitoring, auditing what's going on in the sector. It's not just desk modeling, but rather looking at the actual data and try to see where the government is failing to abide by best practices. We've done comprehensive work into transmission modeling, see how we can expand the transmission grid in a cost-effective way. And we're also looking into, well, the critical issue of variability. Some people refer to intermittency. I prefer variability of renewable energy sources, which can be managed very effectively without building huge amounts of battery. Batteries, of course, are necessary to some point, but it's not an essential requirement for low and medium penetration levels of renewable variable energy. So thank you very much. We have prepared a book on some of those topics for those who might be interested, which brings together both the technology, the policy issues, the regulations, and some of the barriers we are up against when we try to really decarbonize a sector. So thank you very much for your attention.
Thank you so much, Dr. Probst. Fantastic. Next, we'll move to Dr. Shen from Zhejiang University.
Hello, everyone. This is Shen from Zhejiang University, and my research area is primarily in smart, sustainable, and resilient cities and regions. I'm doing right now 2 projects. One is really how curbing urban sprawl when urbanization increases globally. Basically, what I'm doing is combining single-family homes, which are typically constructed on individual parcels horizontally, and together with high rises, so that it doesn't matter you live on 3rd floor, 4th floor, 10th floor in a high-rise apartment, you enjoy a single-family home living quality, and this would will serve land and also reduce prices and reduce urban sprawl. The other things I'm doing right now is global freight transportation, which help the global trade at a national level, international level, and at a national level helps production, economic development in regions and cities. And at a local level, this will help the business development in terms of locations, factories, businesses. And those are the two major projects I'm working on. Right now, I'm working both in the US and China. I worked in 30 years in the US. Just moved back to my hometown in Hangzhou, Zhejiang University. So I appreciate this opportunity and look forward to collaborate with everybody. Thank you.
Thank you so much, Dr. Shen. Next, we'll go to Dr. Pak Chotanen from Chulalongkorn University.
Hi, good morning, everyone. Did you see my slide?
Yes, thank you.
Okay. Today, we're not talking about the environmental sustainability in terms of using the energy, right? From Department of Mining and Petroleum Engineering, Chulalongkorn University. So first, I wanna talking about the research that I did before with the Ministry of Environment, Government of Saskatchewan, Canada, to predict the dust emission using the remote sensing data, because of they have the problem during the spring and summer, and which is the high concentration of the PM 2.5 and PM 10. The major soil problem we guess that from the agricultural activity and the power plant, and the result we found that the high concentration is from the agricultural activities. You can see from the red color. And the second thing I want to talking about, like right now we still need coal to provide a certain degree of energy grid security, right? And in Thailand we use coal for the industry, and during the coal that we import from the other country, we have to find the environmental problems of the distribution of the coal in the ocean and the the river, and then we find the distribution pattern of the coal storage pile, and the coal when like have the smoke, and we gonna provide the information to the coal control regulation in Thailand. You can see the result from the pictures. And the third research I wanna show you is the Tidal floating solar hybrid. Right now we have in Thailand, and we plan to move forward. It's about like 2,700 megawatt in 2037, and we have to find the environmental impacts that come behind the floating solar hybrid with the dam that we gonna create. And then I wanna find the impact between the floating solar and the fish population, that comparing between under floating solar and the outside floating solar, for examples. And the fourth research I wanna talking about the carbon credit that we gonna that we gonna do with the farmer and the industries business. We gonna help them to do the business with a great opportunity to purchase the carbon offset and support the farmer based on the technology and innovation. And also we want to control the methane that coming out after, like, for example, the rice farming that normally they have the big problems with the rice farming with the methane. And the last, this is the example of the CO2 calculation removal. The last research that I want to show you is the CCS that I work with, like university in Canada, and they do the CCS, like CO2 capture and storage, and people concerned about the chemical that coming out after the CCS process, and we call amine. You can see from the pictures, and when the amine coming out, we measure like amine concentration on like every seasonal and exchange where every season. And you can see from the picture, the red color show the serious effect to the community if the amine accidents to the community. Thank you.
Thank you so much, Dr. Petrakantananam. Next and finally, we'll move to Dr. Mildred Warner from Cornell University. And I would also just ask our audience members to put any questions that you have in the Q&A function so that we will move to discussion.
Thank you very much. It's been a pleasure to listen to all these great talks today on the issue of sustainable infrastructure and energy. I direct the local government restructuring lab, so I want to bring us down to focus on the role of the local community. And in that work, I look at sustainable infrastructure, but I also look at finance and service delivery, how these issues affect women and older and younger children, especially, policy and public health, and community and economic development. And I do this work in collaboration with city managers around the world and with planners. So when we think about sustainability, we think about a three-legged stool of a focus on environment, a focus on economic development, and a focus on social equity. And the problem is that there's a forgotten E, and that's the equity E. You can see in this survey of US local governments that only a quarter prioritize social equity. And this is a problem that prevents us from moving forward. For example, I do a lot of work looking at urban drinking water systems. and affordability is a growing challenge. In our study of the 500 largest urban water systems in the United States, we find that the leading contributor to higher prices is private water ownership. The second is drought. The third is state regulatory capture, as state regulations are captured in favor of private providers. And then the last cause is aging infrastructure. All of these are important, and all of these can be addressed with social science research. What factors lead to affordability challenges, especially for low-income families, obviously are poverty, and second, private water ownership. Cornell has been leading in the effort to address new approaches to community water systems, for example, the Agua Clara program that has worked in Honduras and India. And in my college, Art, Architecture, and Planning, we have the Mui Ho Center for Cities, which has labs on water, circular reuse, architecture, and transportation. And then there's the program, the Cornell program on infrastructure policy that looks at finance issues. As we think about the solar transition, we have to realize that this is going to be a major landscape transformation as solar competes for prime agricultural land. That's the challenge we're facing in New York State right now. While we look at the economics of it in terms of agrivoltaics and the possibility of collaborative agriculture and solar through sheep grazing and crops, we also have the problem of demand management as Bitcoin and data mining are dramatically escalating demand for electricity. At the community level, the state, in its efforts to promote increase in solar, has preempted local government environmental review and direct taxation. So we need a balance between environment, energy, agriculture, community well-being, and democratic engagement. And the Atkinson Center for a Sustainable Future has a solar transition working group looking at exactly these issues. I would like to conclude with a model for thinking about this work. In Latin America, there's a concept called buen vivir, community well-being. And what this concept includes is human well-being, community well-being, democracy, and environment. And so you see that the policy layer, the meso layer of environment and infrastructure all relate to the micro layer of family well-being. And to do that, you need active citizenship. Thank you.
Mildred, really a wonderful way to conclude with those holistic thoughts. And as a social scientist, I could not agree more in terms of that family connectedness to the social science side as well as the technology side. So thank you so much for that. Now we're going to move to questions and to allow you to react to one another's presentations and research areas. So I wanted to pose just one, and feel free to all of our panelists to respond by raising your hand or jumping in with your thoughts. But really this connection that was raised by Dr. Heng in terms of the connection between design, technology, and behavior. I want to return to this, or as Mildred put it, right, the connection between from the individual and the family to the community, to the environment, and to officials and regulatory systems. How do we see the possibilities for connection across your various work and expertise areas? Where do you think the most promising potential lies in really taking up that challenge and necessity, as you've put it? And I'm also going to pose, while you're thinking about this one, I'm going to pose one other question from the audience that we've received from our panelists, which is about lithium. And this, I think, refers to Dean Archer's presentation. Lithium has been a primary source for many batteries, both in electronics and cars, but it seems because of a number of reasons, there's an emphasis to other metals. So where is the future headed? And I think that also relates to some of our colleagues' presentations as well.
So I can answer that, Rachel. So I was, in fact, just typing an answer. So that's perfect. So look, so lithium is of interest for a number of reasons. So it's the lightest, most electropositive element, means that you get energy, very high energy density per unit mass, and also very high voltage, which means in a battery system, You need relatively few cells to accumulate the voltage you need to drive an electric motor in a car and so forth. Now, the issue, of course, with lithium is that it's not abundant in the Earth's crust. And we've been looking at alternatives, right? So aluminum is a battery system invented actually in my lab that shows just as much promise. It's trivalent. It can work with water, ionic liquids, and so it's really exciting. Zinc is an older but also resurgent possibility. So as we look to the future where, the idea is that storage isn't just needed for transportation, but also for balancing renewable power generation, we need very, very low cost alternatives to lithium, things that are highly abundant in the earth. Zinc, aluminum, magnesium are some of the elements that people are excited about.
Thanks so much. So to put up maybe a finer point on the first question that I raised, one of the kind of thinking about the processes and the practical steps of implementation, it seems to be agreement across many of you that we need interdisciplinary collaboration around the issues of sustainability. And yet these are certainly hard to build, right, in terms of those different areas that we've mentioned. So what do you see as the best practices for posing questions that take into account these different disciplinary cross-regional perspectives, as well as engaging community and policy participation? So what are the practical steps of building such teams, the processes and incentives that need to be put in place? Yes, Dr. Warner.
Respect. You have to start there because we have a hierarchy in the academy often that you might, privilege the physical sciences over the social sciences, or you might privilege economics over anthropology. And actually, to get at the kinds of questions that we have today, we really do need these very diverse perspectives from all of our disciplines. And you have to start with respect, and you can't have one discipline saying our paradigm or our methodology is so superior that yours don't count. We really need to be very open-minded, and I think that'll lead to new insights.
Yeah, so well put. Dr. Sparatu, Spataru, excuse me.
Yeah, it's okay. I would say a common language and to establish vocabulary right from the beginning when we put such consortium, but a common language really to understand each other, because working in this type of interdisciplinary consortium, it proved really a challenge to understand what we are talking sometimes, because someone in system dynamics, for example, could talk about dynamic systems, but it's not the dynamic systems. What is it with system dynamics in another field, So it's really important to understand that. Another thing to understand is also about quantitative and qualitative research. So there is the tendency of groups focusing on specific topics and so on, which is absolutely fantastic. But we need to be a bit of more open minds to accept that other groups are doing X and Y and Z, and that we need to collaborate. So I think it's really important to think about collaboration. In terms of your first question, and I will be very quick, something that really on the table now is about net zero. And this is becoming like a very high priority for policymakers. And achieving a balance between the carbon emitted removed from the atmosphere require really strategic planning, and reducing emissions from commercial, residential sectors and so on proved to be largely challenged so far. So the business case for the net zero carbon buildings and the circular economy, it's a really great opportunity to create value for developers, for managers and end users. I would say. So there is where research can enable to overcome the silo thinking we have in this moment.
Fantastic. Thank you so much for that. Dr. Dunn.
Sorry for that, my microphone was off. I think I would include to those most valuable answers that came before me that the people to the ones that we try to work for should also be included. For example, in the Galapagos International Architecture Workshop, we try to include the community and not try to impose the answers from the academia. We need the feedback from the community, because maybe when we try to, there might be the possibility when we try to solve something, we might be generating another problem. Yeah, and one of the things that we have developed so far when we engage with the community is the golden rule we have found so far is do not despise any commentary that even may appear with no base at all, or even that may look ridiculous. Let's put an example. If we come to a community in the Galapagos Islands, they're in the agricultural zones of the archipelago, and we ask them what is the things they need the most. Let's say that something may say something silly, for example, we need a circus. It could appear as something that could be as a joke, but behind that answer, the person what is telling you is some real needs or some real expectation from them. For example, entertainment, entertainment for the family. Those are the things that may be the real answer that you need to complement to all the things that you're putting on your proposals. Specifically, when we work on infrastructure, in this case, in sustainable infrastructure, we need to make this not only efficient, but also friendly for the people and the community that is going to live beside it.
Thank you so much, Dr. Dunn. And we'll close with comments from Dr. Shen.
Thank you. I realize that most of the participants right now are from universities, well-known universities, particularly Cornell. I appreciate leading this discussion, this effort. But my suggestion would be three. Number one, could we also add interested organizations, parties from other possibly fields, for example, industry or non-government or nonprofit agency, together with university researchers and scholars. Number two, I think that with the diversities, different topics, projects that I heard, is there a possible way that for us to come up with a common project that supported by UN, World Bank, or other international organizations, that by participating in such a project, that we can possibly find more collaborations, more common goals, and kind of within one project. And third, we probably need to find a more easy and effective ways of communication for any future efforts like this or beyond. Thank you.
Absolutely, so well said. And I think that our the infrastructure that we're beginning to build here hopefully will allow us to continue these types of conversations and to bring in the partners that you are connected with really in this very global approach. And so I appreciate that. We will stay in contact with all of our panelists and audience members. We'll be following up with the information that you've shared here in your slides and links. So thank you all so much for the expertise that you've shared, the really forward-looking agendas that you've put on the table. Obviously, there is much to be done. And to echo Dr. Werner's comments, it's certainly to be done with respect and in collaboration. So we really appreciate you participating today.